All right, that didn't work. Okay. All right. Another hard problem today. This one sounds very similar to the one yesterday but I think the one yesterday was, well, it had a n cubed solution. Maybe this one has like a faster solution, or maybe it's different. All right, you're given 0 index arrays nums of length nums1 and nums2 of length n, both of which are permutations of 0, 1, all the way to n minus 1. Okay, so if they have length 5, then they're 0 to 4, and there's a permutation of those. Okay? A good triplet is a set of 3 distinct values which are present in increasing order by position. 3 distinct values present in increasing order by position, both in nums1 and nums2. Okay, so like if you have 0 through 4, permutation of that, and you have some numbers that are increasing in order and also increasing in order by value and by position, I think. So for instance, 0, 1, 3 here. Good triplet. 3 distinct values which are present in increasing order by position, both in them, in both one. Are present in both an increasing order by position. Okay, so they don't have to be increasing in value. In other words, we consider position 1 as the index of value v in nums1 and position 2v. Position 1 sub v is position of the value v in nums1, and position 2 sub v is the index of the value in position in nums2. And a triplet xyz has it such that for those 3 numbers, the position of those numbers in both arrays is in increasing order. So for instance, 0, 1, 3 should work here. 0 comes before the 1, comes before the 3. 0 comes before the 1, comes before the 3. And that's the only triplet. And then this one may be 0, 4, 0, 3 is one. 4, 0, 3, 4, 0, 2, 4, 1, 4, 0, 3, 4, 0, 2, 4, 1, 3, 4, 1, 2. Okay. Alright, I guess that's reasonable. So find the total number of good triplets. So find the total number of things whereby the position of those values are increasing. Okay, let me think. So I think this feels like a monotonic stack. You care about where things are in order, and if there's a number, is it a monotonic stack? So how would you approach just doing the example here? So if you have the example that is so you have the nums1 is 2, 0, 1, 3, and nums2 is 0, 1, 2, 3. So what you could think about is having a stack where it's like 2 is on the stack for the first. There's 2 stacks, so there's 2, and then there's 0. And then what do you do? I think it doesn't matter the way that you. I don't think it matters. Removal. So you either go to the first 0 or the first 2 in the other array. well, let's see. If you think about starting a good triplet, a good triplet is a good triplet in both. So if I consider, so it doesn't matter whether I find the good triplet as like sourced from nums1 or sourced from nums2, it should be fine in either. So let's say the good triplets are kind of sourced from nums1. So starting with 2, I would need to find where 2 is in the nums2 array, and then proceed from there, I guess. And 2 doesn't have anything after it, or it doesn't have enough numbers after it, so 2 just doesn't work. So then you can go to 0 as your next number, and then from 0 in nums2, you have to restart to the beginning. I wonder, do you need to restart from the beginning? Because that's going to make it slower. It would be ideal if you can just start from a number and then just discard possibilities based on it. Discard, like, just stop considering things. So if you do start for 0 from nums1, that means that nums2 you also have 0. And then the next number there would be like a 1, and you find that 1 can be added. And then the next number there is a 3, and you find that 3 is after the 1. So 0, 1, 3 works. And that's the only triplet starting with 0. Alright, well this is, maybe this is too small of a sample. Okay, let's do the second one here. 4, 0, 1, 3, 2, 4, 1, 4, 1, 0, 2. So for this one, you start with 4 in nums1. You see that there's 4 nums2, and then go 0 nums1, and then you locate 0 nums2, and then you go 3 in nums1, and you note that 3 is after 0 nums2, so 4, 0, 3 is 1. And then it could be 4, 0, well, did I skip over 4, 0, 1? 4, 0, 1 doesn't work because 1 has already been done. Then 4, 0, 3, and then you go back to 4, 0 and try 2. And 4, 0, 2 works because 0, 2 is after the 0. And then you go 0 in nums1, and then 0 in nums2. 0, 1 in nums1 doesn't work. 0, 3 in nums1 works. And then 0, 3, 2, 2 has already been done. This feels like n cubed though. I'm almost certain this can't be n cubed. Yeah, it could be maybe n squared, but it cannot be n cubed. 10 to the 5th if you did that, that would get you too much. That would be too much. Alright, but I'm going to just code it anyways. So let's say n is the length of the numbers. So let's say for every value in nums1, that'll be the starting value. Okay, say start. Let's just say v1. There should be a way to maybe go to that value in nums2. There should be a way to go to that value in nums2. So I think maybe, it would make sense to have a mapping of a value to spot to make it faster. Map value to position. So let's say let's say this map is map for nums. I'll say map 2 because it's map for array 2. It's going to be some integer array times, let's say, size n for every value, for every nums2 value, nums2. Now I need to go through the indices. Every index in range of num, or range of n, map 2. Okay. The value is going to be nums2 at that spot, and then the map 2 is going to be for that value, that index. So for every value in nums1, I'm going to quickly identify where it is in nums2. Actually, alright, let's keep it simple here. So v1 value is going to be nums1 at this spot. And then what position am I dealing with? What's a good naming convention for this? v1 and v1 p2. Value 1 in nums in array 2 is going to be map 2 at this value. And then for every later value, so for this is just an efficient solution here. So for every later index, so let's say j in range index plus 1 to n, I'll have v2 is equal to nums2 at this index. And then value 2 array, so the position of this number in array 2 is that. And then assuming this is, let's break it if it's not okay. So if the position of the second one is before the position of the first one, then ignore this combination. Otherwise, go through the falling spots from j. And this is going to be value 3 is at this spot. Oops, value 2 is at index j. And nums, this is all incorrect. Nums1 index j is value 2. Value 3 is nums1 at index k. And if, no, value 3 index, value 2 position in array 2 is going to be using the map for v3. This should be v2. If the spot for this is after the spot for the second, and the spot for this, well, I don't need a second condition because the other condition is already assumed to be true if this continues after. So this is the answer plus equals 1. Alright, I think, yeah, this should provide something. time limit is seated. Nice. All right. So yeah, that worked. It's just too slow. So for every number, I think I can get down to n squared somehow. If you look at each number, for each number that's after it, you can rule out, you should be able to rule out certain possibilities, if you like. So for each number in V1, so for each value in that order in the first array, you should be able to say that so for each number after it, I think 4 zeros after the 4, zeros after the 4. So is there a way to say that for any two numbers, whether or not those numbers are before or after in the other array? Any two numbers. So if it's 10 to the 5th and you compile, that doesn't make it any faster, I don't think. So for any two numbers, like if you kept track of all the pairs of numbers that are in order in the second array, does it make it any faster? Like you kept 4, 1, 4, 0, 4, 2, 4, 3 as combinations, like tuples or something. Does it make it more efficient to do that comparison here? Like put 4 in the stack, put 0 in the stack because 4, 0 is a combination in nums2. And then you try to put, you can't put 0, 1 on the stack because it's not a combination in the other one. And you can't put, you could put 0, you can't put 0, 1. That feels kind of right. So if you have 4 on the stack, 0 on the stack, 4 on the stack, 0 on the stack, and then you try to put 1 on the stack. 1 is before the 0. So 1 can't go on the stack. So there's no combination where it's 4, 0, 1. But there are still possible combinations where it's 4, 1, and some other number. So when you put 0 on the stack, then it's almost like you should be able to identify the number of good triplets at that point. Because it's 4, it's 0, and then it's every number that is, it's every number that is after both 4 and after both 0, after 0 in both arrays, right? If you have 4, 0, any number that's after 0 in both arrays counts, regardless of where they are, regardless of their like positioning relative to each other. So what does that mean? So you just need to know 4 and 0. You need to know the common numbers between them afterwards. The question is whether or not you can calculate that quickly or if you can track that somehow. So how many numbers are after 0? Well, based on the indexing, you know how many elements there are after the 0. And then if you know how many elements there are after the 0, and you know how many elements there are after 0 in the other one, I guess maybe you could do just like a subtraction. Like there's 3 numbers after the 0 here. There's 2 numbers after the 0 here. So I mean, it can't be 3 numbers that are overlapping. So it's at most 2 numbers. Can you do a set, maybe? So it feels so close. So what if you... So you start with the 4, you go to the 0. So when you go to the 0 here, you keep track of the set of numbers. Now you should already know how many numbers. It doesn't matter. I guess it matters because 4 doesn't necessarily need to be the start. 4 could be somewhere in the middle. 4, 0, put 4 in the stack, 4 in the stack. So for each number, in nums1, you start with that position in nums2. For each number in nums1. So 4 somewhere in nums2. So let's say there's a bunch of crap in between these. So let's say there's like some non-numbers here and some numbers here. And maybe there's some numbers here as well. Alright, so you have 4. you find where 4 is here. Then let's say you eventually process 0. So let's say 0 is the next number that's after 4. That means that any numbers between the 4 and the 0 here are ignored in addition to any numbers before it here. So if you have, and then you have other numbers, let's say eventually you hit 1. Well, currently 40 has it's like 8 numbers after the 0. I think it's 10 numbers overall. Yeah, so there's 8 numbers after the 0. And here there's 3 numbers after the 0. So what does that mean? What does that mean? Like this, let's say there was another number here. Technically, these 3 numbers could be after the 0 as well. Or it could be, this x could technically be here. So there's only 2 numbers that are good for the third number, the triplet. Put 4 on the stack. Put 0 on the stack. So while you could create a set, here and see if these numbers in this set. No, that doesn't make sense. Oh. So for every number after 0, what if you created a, what if you just created a dictionary or a list of all the good pairs, not triplets, but good pairs that are common in both. So or maybe not even that. Maybe for each number, you you kept a count of each number, count the number of values after it that are common in both. So for instance, 0, there's 2 values that are after 0 that is common in both nums1 and nums2. 4, there's well, there's 4 values in both, right? There's 4, 0, 1, 0, 1 through 2, 0, 1 through 2 is after the 4 in both. And for 1, there's 2 common numbers, 3, 2, 3, there's 0, 2, there's 0. That might be, I think that's probably n squared. Unless I can do it with some speed. So I put 4 in the stack, put 4 in the stack. Okay, so let's try this one. So say map value to number to count of values that are that appear after it in count of common values that appear after in both arrays. So let's say, I guess that mapping could be after mapping. Let's say it's going to be 0 for all the indices, all the values, or we'll treat the values as indices. So this can be n squared to do this, I think. So for every index in range n, the value is going to be nums1 at this index, and then for every following index, so j in range k, this value has a count of 0 if the value, so for every following index, so value 2 is equal to nums1 at this index if the spot where you find value 1 is after or before the spot where you find value 2 in the mapping. Oh, so the spot where you find value 1 is also before the spot where you find value 2 in the other nums array. Then that increments the counter. And then after for value 1 is going to be this count. And this is print out to check that this is correct. And this should be everything after index 1. Okay, so 2 has, no, sorry, value 0 has 2 numbers after it in both, both. Value 1 has 1 number after it, 3. Value 2 has 1 number after it, 3. And value 3 has no numbers. Okay, so that's fine. So given that, I can probably just do for every index, there should be an answer. For every index in range n, value 1 is nums1 at this number. And then for every following index, so j in range index plus 1, value 2 is nums1 at this index, and then answer is going to be incremented by however many common ones are after this value. Thought that value, this is bj. Every value 1 nums1. Kind of surprised this didn't work. So index value 1, nums1 index. Let's go ahead and print what's going on here. Print value 2 after at value 2 and the new answer. So starting with 2 as the value 1, if you have 2, 0, there's two numbers that are common both. But there should only be 3 that gets counted because I don't want to count 2. I see. Well, no, that's right. 2, 0, 1, 3. That should be 2, that's right. Okay, and then 2, 1. 2, 0. Oh, I need to verify that the value 1 is after value 2. I see. In the second array. If map2 of value 1 is before map2 of value 2, then ants will then increase. I think this is correct now. Map2. Alright, n squared. Let's see if that is fast enough. Or if this actually is a solution. Time limit exceeded. Huh. Alright, I think this is the same time limit exceeded as the previous one. Okay. So I think there should probably be, so if n squared isn't fast enough, then is there a way to linearly count the number of values that appear after something? Count of common values that appear after in both arrays. So for instance, but this is still not fast enough because this is also n squared. So it just cannot be n squared. Probably is going to be, yeah, it's probably linear, although if this is linear, this seems very small for sample, for an array length. 10 to the 5th, because if it's linear, then you can go like 10 to the 8th or something. So maybe it's not linear, maybe it's n log n. I wonder if it's n log n. Like, that would be binary search some way. You can verify. Can you guess the number of good triplets? I don't think you can guess the number of good triplets. It seems, or if you can you guess the number of good triplets and like do a linear check on that guess to see if that guess is correct or too small or too large. I think that's, let's see how that's used here. All right. map. So for every value and for every this is fast. Like this is linear, that's fine. And if it's linear there, wait, what if you just kept a set of all values thus far at each point? What if you kept a set of values thus far at each point and then iterate through the other array? Iterate through the other array and see what the overlap is between those sets at any given point. So for instance, you have let's say you go through all the indices of the numbers of the arrays. You have a set that goes from 4 to 0 to 1, and then you see how much of that set is part of nums2 up to that point. So that would give you a sense of how much overlap there is. How much overlap there is. But it just cannot be n squared. The n squared part is the tricky part because it pretty much has to be linear at that point. Like you can't go through after you did count. You can't go through the second for loop. Like you can't have an inner for loop to this outer for loop. It needs to basically do the calculation based on like the mappings. It needs to do the calculations based on the mappings. Interesting. So what if you put 4 in the stack, you put 0 in the stack. Four in the stack, 0 in the stack. 4 in the stack, 0 in the stack. Then when you put 1 on the stack, what happens? When you put 4 in the stack, and then you put 0 on the stack, zero on the stack would be there. Four, 0, 1, 3, 2. What if you put 4 on the stack, you put 0 on the stack, then you put 1 on the stack? Four, 0, 1. Could this be a sliding window? Slide out 4, 0. And then what? So if you have 4 and 0, Alright, let's see if I can't make this linear. Let's see. make the mapping of the after linear. So if you go through it in one pass, go 4, 0, 1, 3, 2. Can you determine at any point the number of common things after it is the number of things you haven't already seen? So say for each index in range n, so let's say you have two scene sets. Scene 1 is a set, scene 2 set. Value in nums1 is value 1 at this index. Value in nums2. So we're going to add this to add these values to scene. So scene1.add value 1, scene2.add value 2. So the number of remaining common values is the difference between those sets. So maybe I can't keep track of the difference. So you've seen 1, so value 1 and value 2 is going to be 4 and 4 for next 0. So if the value 1, maybe difference is a set, I don't know. If value 1 not in value 2, then difference adds this value. Do I need to keep track of both? Okay. So maybe there's a difference there. If value 2 not in scene 1. So there's a difference there. And maybe if it's maybe this is something that reduces difference. So if value 2 is in difference, then difference remove value 2. Else, so either a new value was something that was different in both, in which case it removes the difference. In which case it removes a difference, right? Do I need to keep track of value 1 being difference? Whew. So value 1. So the value in nums1. Maybe I should have value 1 and then scene 2. No. Okay, so I've added everything to both scenes. If the value 1 is value 1 is not in scene 2, then difference add value 1. So for instance, it goes 4 and then 0, and 0 is not within the scene of value scene 2, then 0 is a difference, and 0 is going to be added to the set of differences. And then the set of differences, the stuff that's common would be the number of elements remaining. So if it's index 1 and there's 5, and there's 3 index n minus index minus 1, 5 minus 1 minus 1, so there's 3 remaining minus, so minus number in common. N minus, so at that point there's 1 in common, and the answer should be 2. Yeah, minus the length of common, or why am I keeping track of the differences? If I don't see it in the other set, add to the differences. So there's 3 remaining. 1, 3, 2, 0, 2. And because there's 1 differences already, so this is the remaining. Remaining is n minus index minus 1, and the common would be the remaining minus the differences. Now if the value is not in scene 2, there should be a way to remove a difference. If the value 1 is part of the difference, no, value 1 difference should possibly go down. So for instance, when you get to the 1 removes that difference. If value 1 is in difference, then difference dot remove value 1, else. I think this is right. So when you add things that when you add new things for each new value that you see, so the 4, the 0, the 1, that new value either increases the number of differences if you haven't seen it in value in the nums2 set, but if it's already part of the difference, then this is now going to be something that removes a difference. Okay. Okay, let's go ahead and print this out. Let's go and say that the after for value 1, after for value 1 is value 2. So the thing that's in common commonly after value 1 is this. Oh boy, that's not correct. -1, not good. So value 1 is 2, value 2 is 0. So you add those to the sets. Is 2 indifferent? No. Oh. Okay, yeah. And if 2 is not, then let me go and just print this out. Print the after and the difference each loop. And let's say index value 1, value 2. Alright, so the first loop, 2, index 0, 2, and 0 are the values. And then the difference after. The difference is just 2. Yes? No? Yeah, 2 is a difference. I guess 0 is also a difference. I think maybe a difference should be adding value 2, actually. Is that correct? I don't think it is. Okay. So 2, 0, the difference is 0, and there's 2 numbers after the 2 that's common, 1 and 3. That's correct. Index 1, the values are 0 and 1. 0 is part of the differences. So now 0 is no longer difference. But then 1 should be part of the differences now. So if value 1 is indifference, remove it. Okay. I don't think this should be else if. I think this should be else. If value 1 is not in scene 2, so it is in scene 2. The difference should be 1 right now. If value 1 not in scene 2, if value 2 not in scene 1, difference that add value. If value 1 not in scene 2, then what am I adding actually? Maybe this should be the reverse. If value 2 not in scene 1, difference add value 2. And if value 1 is in difference, then remove that difference. But how would you add the... actually, that seems... Okay, this might be actually right. No, it's not. So at the second index, or index 1, the difference, there's going to be one number after 0 that's the same in both, that's 3. It's fine, and the difference between these two sets is 1. The difference is also 2. maybe I'm ignoring 2. The next one is index 2, 1 and 2 are the elements. 1 is now removed from the differences, so there's no differences in both. So there's no differences in both, then it should be setting 0 to this spot though. So n is 4 minus index is 1 minus 1. 4 minus 1 minus 1 is 2. The remaining elements is n minus index. 4 minus 1. Actually, wait, this is correct. Okay, yeah, the remaining elements, there's one remaining element. And that one remaining element, oh yeah, that is correct. Yeah, 4, 1. There's one null element after the 1 that's common. And then 3, there's 0. Alright, that's actually right. And here, after the 4, there's 4 elements in common. Yeah, after the 3, there's 0 elements. Oh, sorry, after the 0, there's 2 elements. After the 1, there's 2 elements. After the 3, there's 0 elements in common. After 2, there's 1. Okay. Okay, so that does work for counting in linear time this thing previously. Didn't look like I actually needed scene 2. So yeah, so value 1. If it's in the difference, remove it from the differences. If value 2 wasn't in scene, then add the differences. Then the common stuff would be the remaining part, which is n minus index minus 1 minus the length of the differences. Okay. And then if I just use this thing for the rest of the code, this should work for the simple cases. We'll time out for the long case. Okay, so so I got down to linear time for that calculation. Now I just need to consider the counts without. So if you have 4, 0, so you put 4 in the stack, put 0 in the stack, you can immediately go to your after array to get the number of common stuff. And then what? And then you have a 1. Well, what happens when you have the 1? So 4, you put 4 on the stack. You can put 0 on the stack because 0 comes after the 4. And then you cannot put 1 on the stack because 1 doesn't come after the 0. So you pop 0 off the stack. Then what happens if 0 is the possible starting value? Because you're not going to be coming back to this. Put 4 on the stack. Put 0 on the stack. Four on the stack. 0 on the stack. You try to put 1 on the stack. But because you can't put 1 on the stack, no, you put 4, 0. So you've done all combinations that start with 4, 0. Now you do 4, 1. Four, 0. For each number, let's go ahead and just double check to see that time limit still exceeded here. Yeah, it's definitely exceeded. Oh, it's the wrong answer. Oh boy, that's not good. Let's go ahead and print after here. Actually, it's so 13, 3, how to read this? For each index, for each value in range n, print the value and okay, so 0 after in common is 1. No, that's not correct at all. 1, well, was this correct? 0 after that in common was 1. That's not right either. Zero after that in common was 2. 1 after that in common is 2. 2 in common is 0. So this was not right first off. 0 in common should have been 2. Okay, so value 1 was 2, value 2 was 0, index was 0. So scene 1 at the first value. And if value 1 was in difference, remove it. Value 2 is not in scene, add that to the differences. I thought this was correct before. What was it before? I think this was what it was before. Okay, so let's go ahead and see if that works. again. Okay, so print after at index 0 or at value 0, there should have been 2 there. No, this is not correct. So if value, so you're keeping track of your differences, but you're only removing differences based on. Okay, so maybe I just need to be more thorough here. If the value 1, if it's in differences, remove it. If value 2 is in differences, then remove it. If value 2 is not in scene 1, if value 1 not in scene 2, then add it. Okay, how about that? Now the second case doesn't work. As well as the third case still doesn't work. Alright, go back to more printing. So print value 1, index, value 1, value 2, the differences, and how much is in common. Okay, so 4, there's no differences. After the first one, there is a difference. And there is one. The length of differences is probably not correct here. I think this might be length of differences divided by 2. Alright, I think this should be divided by 2. Okay, so 22004 is correct there. This is still incorrect. What's wrong with this one? So after 0, there should be 2 numbers in common. So after 0, so there's a 1, 3 that's there. So 1, 2 there. So the difference between these two and these two are there's a 1 and there's a 2. And because there's 2 remaining, there's 2 remaining, and there's 2 remaining, there's 2 remaining, and the difference is basically 1. Yeah, that logic just doesn't work, because somehow it doesn't keep track of 0 occurred over there. Okay, so what am I actually trying to do here? So for each index, let's just reconsider this. So index in range n, value 1, value 2 are the numbers at that index in those array. So the remaining I'm giving so for 2 so for each number here 2 occurs here and 2 occurs here. If I keep track of the number of common elements up to that spot, so the number of common elements up to that index. Okay, I think maybe I need to have a separate loop here. Common is going to be 0 times n. Let's just say I kept track of the number of things in common up to that spot. How would I do that? For each number, it's either going to be, well, yeah, so let's say value 1 is added to scene 1. And value 2 is added to scene 2. And keep track of the differences. Maybe we can keep track of the common stuff. So it's easier to keep track of the difference with common stuff. So if value 1 in scene 2, then common.add value 1, and value 2 is in scene 1, then common.add value 2, and common at this index is equal to the length of common. Common count at this index is equal to length of common. And then for after that, for each index, actually for each value in range n, I think I need to know the mapping of, actually for each value in the nums1 array, then it should be the index. For each index in range n, value is going to be the value nums1 at this index. And then I'm going to look at the position 2 is the spot where this value occurs within the other array. And it's going to be the common, it's going to be the latter common. It's going to be the index of the common things. Whichever occurs later, this index for position 2, it's going to be the common of that. So after of this value is equal to common count for the later of this index and the other index. Okay. Slow and steady. common count of this index. Did I misspell it? Common is not defined. Oh. Common is a set. Okay, so index value 0, there's one thing in common. Oh, shucks, that's not correct. Huh. Okay, let me print out what common count actually gives out. So index 0, there's 0 things. There should be 2. Common count at this index. Okay, let's go ahead and just put it here. Value 1, index, value 1, value 2. What's in common and the common count array. So at index 0, there's 0 elements in common. Okay. At index 1, 0 should be in common. Okay. Index 2, 3 things should be in common. Okay, yeah, that's right. I think I have this reversed. After is the number of remaining elements that are in common, so not the number of things before this that's in common. So if you have some number of things before this that's in common, then can you determine the number of things after this that are in common? So I could just go reverse order and go index reverse here. So let's say index from n minus 1 to negative 1 to negative 1. So you have your ending values. You have your ending values. Okay, maybe that might be. Okay, so what does this say? So after 0, there's 2 things in common. After 1, there's 1 thing in common. After 2, there should be 1 thing in common. After 3, there should be 0 things in common. There should be 0. So I think maybe I should be adding the common count at the start. Because at the start, you don't actually have 3 as part of your common count. Okay. Yeah, that's right. That's not right actually, because after 0, there should be 2 things in common. Common count. Oh wait, maybe I'm looking at the wrong thing. This is right now. And then after 0, no, that's still wrong. After 0, there should be 2 things in common. So if I look at 0, the position of 0 is either 0. Yeah, so after 0 in common here, no, it's not. It's not just the position of 0. It's position. Doesn't really matter what the position of 0 is actually, because it's two things in common here, two things in common here. So how to do that? So if I know that there's two things in common after this, no, I don't track that at all. Okay, so how would it make sense? For each value in your nums1 array, so you have 2. Try to figure out how many things are in common between how many things are after 2. What if you did So what if you had a set for nums1, 2, 0, 1, 3. And then for nums2, you go through the numbers of nums2, and you do what exactly? If you go through the numbers nums1, so you see 2's there, and you see 2's there. You see 2's there, you know 2's at this spot here. We strictly care about the numbers after this 2 that's in common. Up here. Just the numbers after this 2 are in common here. So that'd be 1. So I think it's after the common count after that number in position 2. Okay, so 0 has 2 things in common, 1 has 1, 2 has 1 thing in common, and 3 has 0. Okay, 0 after in common is 2 and 3, so it's 2. 1 has 2 and 3, that's 2. 2 has 0 things in common. 3 has 0 things in common, and 4 has 4 things. Alright. Let's go and just remove some of this print. Alright, so the after part. After 0, there's nothing in common. After 6, there's just one thing, the 1. 0, 1, nothing common, 2, 2. After 2, there's 3 things in common. Oh boy, I don't know what 3 things there might be. So 0 is 1, 0, 1, 3, 0, 1, 3, 4. That's already more than 3. 0, 1, 3, 4. So why didn't this work? So I think we might need this. Alright, starting with the last index. 1, 0. Nothing is in common. 14, 5, 1. One thing's in common though. 1. 13, 6, 12. Only the 1. 12, 0, 3. 2 things in common. 0 and 1. Okay. I think the common counts are fine. So once I have the common count, each index in range n, for each index in this range, the value would be 13. And then I'm looking at position of this value and the other one. So this position, and then the common count of stuff after this thing. Huh. Okay. Seems fine. So 0, 3 here just doesn't work correctly. 0, 1, 2. So after the 2 here, the things that are in common would be yeah, that still doesn't work correctly. Because after the 2 here, things that are in common would be 1, 4, 0, 3. Actually, after the 2 here, the things that are in common should be 0, 1, 3, 4. So there should be 4 things in common. Somehow I got 3. Gosh dang it. Value 1's insane. The add to value 2. Value 2 is insane. Add to value 2 to common. Index. The value of nums 1. Position 2 is the map 2 of this value. go. Well, in theory, that shouldn't work either. I don't think, maybe. Because what if 2 actually occurred earlier on here? Then, yeah, this only works in kind of specialized cases. How did I have it before? I went through for each number. I went through every number and did a manual count. Yeah, that theory that doesn't really work. Like, if you look at the 2 here, and you assume the 2 could have been over here, just because you counted the number of things here, doesn't work. It has to be the lower of the 2 common counts. No, it doesn't have to be the lower of the 2 common counts. Yeah, it is below the 2 common counts, I think. How many elements are in common after something in one array? How many elements are in common after something in... So the number of elements that are in common it should be all. So here there's 16 elements. And because the first 2 numbers are different, then after the first index, 14 are the same. So the number of things that are the same in both should be a decreasing amount as you increase the index. So am I dealing with a common? So yeah, so it's an increasing amount of things that are in common. The remaining elements that are in common. There's 0 remaining elements that are in common at the end. And there's 0 remaining elements that are in common at the end here. Shouldn't this be the position of the later one? Because the later one has the smaller amount of things in common. After. Huh. This one clearly didn't work. I think I definitely had this before. Position index. Whichever later one occurred. Yeah, didn't work. So 0 somehow. There should be two things in common. Zero. Okay, so the common count here is after index 0, there's two things in common. After index 1, there's one thing in common. After index 2, there's one thing in common. After index 3, there's 0 things in common. Okay, so I think the common count there works. So for each index in the range, the values can be 13, 14, 10. So for 13, the position of that and the other one is over here. And the things that are in common is either the smaller well, it's the later one of these two, so it's this position. And then at that position, there's 1, 2, 3, 4. 1, 2, 3, 4. So after value 13, which is like this value, there's 16 elements. So 15, 14, 13, 15, 14, 13. There's two elements in common after the 13. That'd be 0, 1. There should be 3 elements, 0, 1, and 3. Huh. 0 in common after the... Why is there only 1 in common? Should be 0, 1, and 3. So after the 13, yeah, this is after this 13, but then it's after this 13. Okay. Oh my god, screwing this up so badly.